Identify the image of triangle X under the given rigid motion. So X is going to be the original in all of these problems. We're looking for the one that translates along NO. So that is moving towards the right. If we take this figure and we move it towards the right, we would end up at C. So in this first one, if you translate X along NO, that is now at figure C. If we were to take figure X and reflect it across line L, remember you can flip that tracing paper over and you are lining it up on the line, and we've ended up at figure A. So again, we are going to write down, after the reflection, you ended up at figure A. Please complete the remaining 3, keeping in mind X is going to be the original for all of them. Where would you end up after a rotation? How about a translation going the opposite direction? Or a rotation around P, 90 degrees clockwise. Those say the same thing, so let me check and make sure there's not a typo. Number 5 should say counter. 1. Will figure A, B, C, D map onto figure E, F, G, H by using the following sequence of rigid motions? First, apply a 90-degree counterclockwise rotation around point X. Point X is located directly below point C. To perform a rotation, you need a straight line going through your center of rotation, and then you also need to use your protractor to create a mark at the desired angle, which in this case is 90. So pulling out that protractor, we're going to line up our protractor on the line we created, and the center of our protractor should be lined up on the center of rotation. Create that mark at 90 degrees, and then connect it using the straight edge. Now I'm going to trace the figure A, B, C, D and the line through the center of rotation. Selecting both of those, I'm going to rotate until it lines up on the 90-degree angle mark. Remember to keep your pencil held on X. Now we also need to reflect across line M, and M is a vertical line to the right of CD. So vertical meaning going straight up and down, and it's on the right side of CD. So we are going to take this figure and this line and we are reflecting over the line. Will it map to E, F, G, H? Now, keep in mind that my location of point X may be slightly off because it doesn't give me specifics. If I were to have scooted that down, that would also impact this piece here, and the location of this line could be shifted to the left or to the right. But it does appear that it, when rotated 90 degrees, is oriented in the same direction. So will these figures map onto each other using these motions? Yes. But we do run into some problems because it doesn't give us the specific locations of point X and line M. So in order to make this more effective or more efficient, to be able to determine if they map onto each other, we need to be provided with the location and the line in which we are reflecting over. So it is possible, but it's going to take multiple trials to get them in the perfect spots. For problems 2 and 3, describe a sequence of rigid motions that show the given mapping. Draw any vectors, lines of reflections, or centers of rotations that are needed. Now, keep in mind the order in which these things are labeled tells us specifically which points correspond to the other points. So A matches up with point D. B matches up with itself, and C matches up with itself as well. So how could I get A to move down here to D? If I were to trace A, B, C, how could I get this triangle to turn into this bottom triangle? This appears to be a reflection. And if I reflect it, I could end up down here. Now, where is that line of reflection occurring? It appears that they need to reflect over this line in the middle. So we can draw in that line, and it goes through BC, and we can label that line, line L. In this one, we want A to move to point D. We want B to be lined up with B, and we want C to move to point E. This appears to be a rotation to me, and it looks like they are going to rotate 180 degrees. And you can see that rotation on the side there in that circle. Rotate 180 degrees. And where would we place our pencil? We need to rotate around point B in order to stay with B lining up with B. So this is a rotation 180 degrees. We went counterclockwise. From center, and we use B as our center of rotation. For ABC to be mapped to DBE, we're going to start by rotating. We're going to rotate, and it appears to be 90 degrees clockwise. I'm going to write A over here because I don't have enough room down at the bottom. Rotate 90 degrees clockwise about center B. And then that's going to place it looking like this here. Lined up on BE. So then to get it to move to this position, we would need to reflect it over to that side. So then we are going to draw in that line here. And give it a name. So then we will reflect over line L. For B, we are going to go the opposite way. This is now the new, so we can switch it. We can reflect it first, and then we can rotate it this direction to line up there. So reflect over line L, and that's going to put it here. And then we would rotate about B again, but this time we're going to go 90 degrees counterclockwise. So here again, keep in mind that the corresponding points are listed together. So the first one, A, corresponds with D. B would correspond with B. And point C corresponds with C. The way that it's written in these triangle congruences is based on which points correspond to each other. For problems 5 through 8, describe the sequence of rigid motions that maps one figure onto a congruent figure. Draw any vectors, lines of reflection, or centers of rotation that are needed. To start, I'm going to try and map one point onto another. That way I know at least one piece of the transformation. So I'm going to start by mapping S to N, because right here I see S and N are the last letters. So what that's going to look like is I'm taking this figure and shifting it down to the right. So I'm taking this figure and I'm sliding it down along that vector until S and N match up. Now, it appears that I need to turn it. So I'm going to first write down translate along vector. We label vectors based on their starting and ending point. So S to N. Started at S, ended at N, and we're labeling it with this little half arrow on top. That's the notation we use for vectors. Then we are going to rotate, and we're holding our pencil on point N. So rotate, and we're going to go clockwise about point N. Now, I don't know the specific angle measure. It looks just over 180 degrees, but we are going to rotate this figure clockwise until it matches up. And it should look like so. You don't necessarily need the angle measure. You can say until RA or RAKES maps to this one. And in this, it doesn't tell us which figure is the original. We just need to show they are congruent, that's what that symbol means, by mapping one to the other. So THE is congruent to GUM. Notice here, this one has 3 little lines, so this one maps to M. You can also see E and M are the last ones in the congruence. So first thing I would do is I would translate to get one point to match up with another. T and G go together, so I'm going to translate along TG. We started at T and ended at G. Use that little half arrow. So this is sliding down along the vector until T and G match up. Then I can rotate. So then I can rotate around point G. I need this whole figure. If I rotate around point G, you might notice that I have 3 lines here, but it should be over here. So I'm going to actually rotate about G until it matches up to this line segment GM. And then I need to reflect it because this piece needs to stay here. If I continue to rotate, I'm going to put the wrong angle in that spot. So I can reflect over this line here. So that's going to take this figure here and it's going to flip it over this line to match it up. Number 7. I see T and G match up, B and R match up. So I'm going to start by translating to get G and T to line up. So translate along vector G to T, include that little half arrow. So we're taking this triangle and we are translating it up along this vector. And now I'm going to reflect it over into its new location. Let's draw that line in there. We can label it whatever. This time we'll label it M. And it's going to flip this to its new location over here. I matches up with D. E matches up with T. So I'm going to translate E to T. So we'll take this figure and we're going to slide it up along this vector until we line up here. Now I want I to go to O. If I just rotate it around T, that's not going to get I to go to O. So I'm going to rotate to start. I'm going to rotate about point T. I'm going to hold my pencil there, and I'm going to go clockwise until this point P maps to point D. So I'm rotating until it lines up there. Now I need to reflect it in order to get I and O to match together. And I can draw that line in there. We can call it N. And this is going to flip it into this location. Make sure your warm-ups and your workbook are filled in to complete today's lesson.